Welcome to Database Security Fundamentals. In this session, we'll cover security issues and requirements in database systems, providing you with essential knowledge to protect your valuable data. What exactly is database security? It is the protection of database systems against intentional or accidental threats. This involves ensuring the confidentiality, integrity, and availability of your data. The goal is preventing unauthorized access, modification, or destruction of your valuable information. The key objectives of database security are to protect sensitive information from unauthorized disclosure, prevent unauthorized data manipulation, ensure data remains available to authorized users when they need it, and maintain regulatory compliance with relevant laws and standards. Let's explore some common threats to database systems. Understanding these threats is crucial for implementing effective security measures. First up is SQL injection attacks. Then comes excessive privilege abuse, followed by weak authentication. Then there's backup data exposure, denial of service attacks, and finally, malware and insider threats. Let's dive deeper into each of these threats. SQL injection is a code injection technique where malicious SQL statements are inserted into entry fields for execution by the database. This attack can allow unauthorized individuals to bypass authentication, gain access to sensitive data, modify existing records, or even delete entire tables. Here are some examples of vulnerable and secure code. In the vulnerable code, user input is directly embedded in the query string, creating an opening for injection attacks. An attacker can insert malicious code such as admin followed by a comment, which comments out the rest of the original query, hence bypassing the password check. In the secure code example, prepared statements are used. These statements ensure that user input is treated as data, not code, effectively preventing SQL injection attacks. Let's delve into the foundational principles that guide database security. These core principles ensure that your data is protected, accurate, and accessible when needed. First, there is confidentiality, where we ensure that data is accessible only to those authorized to access it, protecting sensitive information from unauthorized disclosure. Examples include data encryption, both when stored and during transfer, the implementation of access control mechanisms, column-level encryption for sensitive fields, and data masking for non-production environments. Second is integrity, which involves maintaining and assuring the accuracy and consistency of data over its entire lifecycle, preventing unauthorized modification of data. Examples include database constraints and validation rules, digital signatures and checksums, transaction controls and asset properties, and audit trails and change tracking. Lastly, we have availability, ensuring that authorized users have access to data and resources when needed and preventing disruption of service or data access. Examples include database replication and failover mechanisms, regular backups and recovery procedures, high availability configurations, and DDoS protection mechanisms. Now, let's explore the different models for controlling access to your databases. These models determine how permissions are granted and managed, ensuring that only authorized users can access specific data. First, there is discretionary access control or DAC, where access rights are determined by the owner of the object. An example of DAC is where an owner controls permissions by using the grant statement to grant select and insert permissions on the customer's table to the sales_user. Then comes mandatory access control or MAC, where access is determined by system-wide policies that cannot be changed by individual users and is based on security classifications. An example of MAC is where data is labeled with sensitivity levels to control access based on user clearances. Next is role-based access control or RBAC, where access rights are assigned to roles and users are assigned to appropriate roles, which simplifies administration for large systems. An example of RBAC is creating a role called analyst, granting select permissions on reports to that role, and then granting the analyst role to a specific user like Jane Doe. Finally, there is attribute-based access control or ABAC, where access decisions are based on attributes of users, resources, actions, and environment providing fine-grained context-aware control. An example of ABAC is that users can only access records from their own department during business hours. Let's discuss various database encryption techniques. Encryption is a critical tool for protecting sensitive data, both when it's stored and when it's being transmitted. Firstly, we have data at rest encryption. This includes transparent data encryption, also known as TDE, encrypting database files at the file system level and protects data and log files without requiring application changes. Secondly, there's column-level encryption, encrypting individual columns containing sensitive data like credit card numbers, social security numbers, or personal information. Then we have data-in-transit encryption. This includes transport layer security, or TLS, also known as SSL, encrypting data as it travels between client applications and the database server, preventing eavesdropping and man-in-the-middle attacks. Secondly, there's API-level encryption, where the application encrypts data before sending it to the database and decrypts it after retrieval, providing end-to-end protection. Let's delve into database auditing and monitoring. These practices are crucial for maintaining security, ensuring compliance, and detecting suspicious activities. Database auditing tracks and logs database activities to maintain security, ensure compliance, and detect suspicious behavior. It provides a record of who did what, when, and how. Key events to audit include login attempts, both successful and failed ones, data access and modification operations, schema changes and data definition language operations, security policy changes, and administrative activities. Here is an Oracle database audit example. First, enable auditing for specific actions, such as auditing select statements on the HR.employees table by access whenever successful. Second, create a fine-grained audit policy using the dbms_fga.add_policy procedure to audit access to the salary column in the HR.employees table. Let's review some of the best practices for ensuring robust database security. These practices can help you protect your data and systems from various threats. First, implement strong authentication, which includes multi-factor authentication, password policies, and centralized identity management, and avoid default or shared accounts. Second, apply the principle of least privilege by granting only the minimum permissions necessary for users to perform their job functions, and regularly review and revoke excessive privileges. Third, carry out regular backups by implementing automated, encrypted backups with regular testing of restoration procedures, and storing backups securely offsite or in separate environments. Fourth, implement vulnerability management by regularly applying security patches and updates, and conducting periodic vulnerability assessments and penetration testing of database systems. Fifth, put comprehensive auditing in place by enabling detailed audit, logging for security-relevant events, and implement automated monitoring and alerting for suspicious activities. Finally, use data masking by implementing data masking or anonymization for sensitive information in non-production environments to prevent exposure during testing. Let's summarize the essential concepts we've covered in this session. Database security is a multi-layered approach that protects data confidentiality, integrity, and availability through technical controls and policies. SQL injection remains one of the most critical threats to database security, requiring proper input validation and parameterized queries. Effective access control models such as DAC, MAC, RBAC, and ABAC are essential for enforcing the principle of least privilege. Encryption protects data both at rest, like through transparent data encryption and column-level encryption, and in transit, such as through transport layer security, forming a critical defense layer. Comprehensive auditing and monitoring are necessary for detecting security incidents and maintaining compliance. Security is an ongoing process requiring regular updates, vulnerability assessments, and adaptation to emerging threats. Here are some further learning resources you can use to learn more about database security. This includes the OWASP Database Security Cheat Sheet, CIS Database Security Benchmarks, and the NIST Database Security Guidelines. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.